Hello everyone. Welcome to my latest video. Today, we'll be exploring a vulnerable machine called GoldenEye, classified as intermediate in terms of difficulty. This machine is inspired by the iconic James Bond film, and even better N64 game, GoldenEye. Our objective is to gain root access and capture the secret GoldenEye codes in the flag.txt file. To get started, visit the VulnHub website and download the vulnerable image. If you're new to VulnHub, check out our VulnHub playlist for some helpful tutorials. Settings up. Once you've downloaded the image, the next step is setting up the server in VirtualBox. This process is quite simple and involves importing the OVA file into VirtualBox using the Import Appliance feature. Importing the OVA file into VirtualBox is a straightforward process. Here's how to do it. To import an OVA image, navigate to the menu bar and click on File. From the drop-down menu, select Import Appliance. This will open the Appliance to Import window, where you can browse and select the OVA image from your local storage. Click Next, and the Appliance Settings window will appear. Now, review the appliance details and settings. You can adjust them as needed. Click Finish to start the import. Once the import is finished, you'll see the GoldenEye V1 vulnerable machine listed in the VirtualBox Manager under the VulnHub group. Select the virtual machine, go to Settings, and change the network adapter to Host-Only Adapter. It's important to ensure that both your Kali Linux machine, used for attacks, and the vulnerable machine are connected to the same network. So make sure they're both connected via the host-only adapter. Now, it's time to start the VM. Now, you'll notice that our vulnerable machine is ready, with a login prompt awaiting. Let's dive into the fun. Enumeration. The initial step in our attack is enumeration, which involves identifying the IP address of our target machine using netdiscover. To execute this, open a terminal and run netdiscover-i followed by specifying the network interface name, which in this case is ETH1. From the scan results, we've obtained our target IP address, 192.168.95.19. Next, we'll conduct a network scan to identify open ports, a crucial step in the enumeration process. This helps us understand the attack surface and strategize targeted attacks. We'll use the popular nmap tool for this task. Run nmap-sc-sv followed by specifying the IP address. In this command, -sc is used to perform a script scan using the default set of scripts, while -sv enables version detection, allowing us to identify which versions are running on which port. After completing the network scan, we discovered two open ports. Port 25 TCP, this port is commonly used for the Simple Mail Transfer Protocol, SMTP. The scan identified the service version as postfix SMTPD and detected features such as pipelining, which allows multiple commands to be sent without waiting for responses. The ability to send large emails, and TLS encryption for secure communication. Port 80 TCP, this port is commonly used for HTTP web traffic. The scan identified the service version as Apache HTTPD 2.4.7 Ubuntu, and found the web server title to be GoldenEye Primary Admin Server. This indicates that the server is running on Ubuntu and is labeled as the GoldenEye Primary Admin Server. Now, let's explore the content of the website running on port 80. To look at the contents ourselves, open a web browser of your choice, and navigate to the target's IP address in the URL bar at the top of the window. Upon exploring the web page, it appears to be a Severnaya auxiliary control station, suggesting it might be a control panel for a system named Severnaya. The login page displays a warning, top secret access, and provides server details, server name, GoldenEye, user, unknown. The login page instructs users to navigate to Sevhome to proceed. Let's see what awaits us there. Upon navigating to Sevhome, we encounter a login prompt requesting a username and password. Unfortunately, we lack the necessary credentials to proceed, so our first priority is to find the credentials. Since brute forcing credentials is not recommended, let's explore alternative methods. We can use the browser's developer tools to gain insights into the login page. By right-clicking anywhere on the page and selecting View Page Source, we can access the underlying HTML code. Within the source code, we discover a JavaScript file named terminal.js embedded within a script tag. This file might contain valuable clues for our investigation. Let's examine the contents of terminal.js to see if the developer left any hints for authorized access. Our inspection of the JavaScript file reveals an interesting piece of information embedded within the code. While we won't disclose the exact details here, it appears the developer intended to provide a hint for a legitimate user, Boris, and encoded a password in the script. It seems Boris is the username, and the encoded text looks like the password. Since it is encoded, let's search for it on Google. While searching, the text automatically decodes to Invincible Hacker. For better verification, we can use an online HTML entity encoder-decoder, which confirms the same result. Now that we have a valid username and password, it's time to log in as we had attempted earlier. Upon accessing, it shows the description of GoldenEYE. GoldenEYE is a top-secret Soviet orbital weapons project. Since you have access, you definitely hold top-secret clearance and qualify to be a certified GoldenEYE network operator, GNO. Please email a qualified GNO supervisor to receive the online GoldenEYE operators training to become an administrator of the GoldenEYE system. Remember, since security by obscurity is very effective, we have configured our POP3 service to run on a very high non-default port. Upon analyzing the description, it mentions that the POP3 service is running on non-default high ports. Use this information to locate and access the POP3 service, which can help in gaining a foothold in the server. To get to know if there is a POP3 service running, we can again conduct a network scan to identify open ports using Nmap. Here, I am going to scan all open ports. Upon completion of the network scan, we discovered two open ports. 55006 TCP, this port is open and uses the TCP, Transmission Control Protocol, for communication. TCP is a reliable protocol that ensures data arrives in order and without errors. 55007 TCP, similar to the first port, this is another open TCP port associated with the POP3 service. Both ports seem to be running the POP3, Post Office Protocol, service, likely via the Dovecot mail server software. POP3 is a standard protocol used to download emails from a mail server to a local email client, like Thunderbird or Outlook. It typically uses port 110, but in this case, it's running on non-standard ports, 55006 and 55007. Since the POP3 service is running, it means we can establish a connection to view the emails exchanged between various users. For this purpose, we can use the Telnet client tool. Here's how to proceed. Open your terminal and type Telnet. Specify the target IP address. Specify the port that the POP3 service is running on. In this case, we will first attempt to connect on port 55006. On previous web enumeration, we found a username, Boris, and a password, InvincibleHack3R. Let's use these credentials. Upon connecting to the target IP on port 55006, we will use the username, Boris. Unfortunately, the connection is closed by the foreign host, which indicates that port 55006 is not usable. We have another open port, 55007, so we will use this one to establish a connection. Upon successfully connecting to port 55007, the server displays a +OK confirmation, indicating that we have accessed the GoldenEye POP3 electronic mail system. Upon inputting the username, Boris, the server responds with +OK, confirming that the username is valid. Next, input the password InvincibleHack3R. But the server responds with ERR, auth, authentication failed, indicating that the password is invalid for the username, Boris. Since we do not have a valid username, let's conduct a password attack on the POP3 service running on the target machine for the user, Boris. For this purpose, we will use Hydra, a powerful tool for brute force attacks. Where a -l is used to specify the known username to use, that is, Boris. A -P is used to specify the path to the word list file, flag.txt, containing potential passwords. -F is used to tell Hydra to stop after finding the first valid login. Next, we need to specify the IP address of the target, 192.168.95.19. -S is used to specify the port number, which is 55,007. Finally, specify the protocol to attack, which is POP3. Upon initialization, Hydra initially attempted up to 16 login tasks simultaneously, with a total of 262 login attempts to be made. In the end, multiple error messages appeared. These errors indicate that the POP3 server disconnected the Hydra client due to inactivity during the authentication process. This likely means that the server has a timeout setting that disconnects idle connections during login attempts. In the end, Hydra completed the attack on the target but did not find any valid passwords. To address the inactivity disconnections, we can try to increase the task number. Increase the number of parallel tasks to speed up the process and reduce inactivity periods. Use the -T flag to specify a higher number of tasks. The -I enables immediate execution mode, starting the attack without delays. By increasing the number of parallel tasks and using immediate execution mode, Hydra successfully finds a valid password for the user Boris for the POP3 service. Now that we have the password, let's continue to establish the POP3 connection, which was previously disrupted due to the lack of a valid password. Upon inputting the password, the server responds with +OK logged in. This indicates that we have successfully logged in to the POP3 service. Now, it's time to retrieve the mail. To retrieve the emails, run the list command. The server responds with +OK 3 messages, indicating that there are 3 messages available. To read the content of any of these messages, run the retr command followed by the sequence number of the message. The retr1 command retrieves the first email, which includes headers and body content. Upon analyzing the admin statement, I figure it out a potential security weakness. The admin statement about not scanning emails for security risks highlights a potential vulnerability. This could be exploited to communicate sensitive information without detection, posing a security risk. Let's proceed with further actions by retrieving additional emails to gather more information. Analyze the contents of other emails for any actionable intelligence or further security insights. The retrieved email contains a concise message. Boris, I can break your codes. This statement suggests that the sender, identified as Natalya at Ubuntu, claims the capability or intention to decrypt Boris's codes. Upon reviewing the emails, while no immediate valuable information was found, it became apparent that Natalya appears to be another username associated with the system. Since we have identified the username Natalya but lack the corresponding password, the next logical step is to attempt a password attack using Hydra. Hydra successfully cracked the password for Natalya on the POP3 service. The password found is bird. The successful cracking of the password, bird, for Natalya grants unauthorized access to the POP3 service. Since we have another valid username and password, let's establish a connection against POP3. Login was successful. Now, it's time to retrieve the mails. To retrieve the emails, run the list command. The server responds with +OK 2 messages, indicating that there are 2 messages available. To read the content of these messages, run the retr command followed by the sequence number of the message. The retr1 command retrieves the first email. The email reveals internal communications within the system, addressing specific roles and responsibilities. Mention of attempting to break Boris's codes and caution about network breaches suggests ongoing security risks and concerns. The content highlights operational directives and alerts intended to manage and mitigate potential security threats. This analysis provides insights into the operational dynamics and security posture within the GoldenEYE system. It underscores the importance of monitoring and securing network operations, especially in light of external threats like the Janus crime syndicate. Further actions may involve implementing enhanced security measures and vigilance to safeguard sensitive information and maintain operational integrity. Let's retrieve and analyze the second message from Natalya's mailbox. This email contains essential information about operational procedures and security practices. The email outlines the steps for managing new user accounts and highlights the importance of reporting system configuration issues, particularly those related to security. This proactive approach helps maintain system integrity. The email provides access credentials for a new user, Xenia. Boris has verified Xenia as a valid contractor, authorizing the creation of her account. Natalya is given an internal URL, servernea-station.com/gnosert-dir, and instructed to update her the host's file to access it. This URL is likely essential for her training and operational tasks. Since Natalya uses a Linux environment, she is instructed to point the server's IP to servernea-station.com/gnosert-dir in the /etc/hosts file to ensure proper access to the internal domain. From the analysis of the message, first, we have to update the host's file. To access the internal URL, we need to modify our system's /etc/hosts file to map the target's IP address to servernea-station.com/gnosert-dir. Open the /etc/hosts file in a text editor with root permissions. Add the following line to map the target's IP address to servernea-station.com. Once the host's file is updated, we can visit the internal URL to proceed with any necessary tasks or further investigations. On the web browser, navigate to http servernea-station.com/gnosert-dir. Upon navigating to the internal URL, we see the dashboard for GoldenEYE Operators Training Module. This page displays available courses and other relevant information. In the upper left corner, you will find a login button. Click on the login button. Upon clicking the login button, it will be redirected to a login area. Here, you can either log in using valid credentials, username and password, or opt to log in as a guest if that option is available. In our previous steps, we discovered the username and password needed to access the system. Let's use these credentials to log in and explore further. Input the username and password found earlier. Upon successful login, the web page will display the GoldenEYE Operator Training Portal. Upon logging into the training portal, you will see the following features. Here, it displays a welcoming message that greets you on the main page. A calendar component is displayed on the right side of the page, and a navigation menu on the left side provides links to various sections of the training portal. This menu provides links to various sections of the training portal, including Home, My Courses, My Profile, Settings, and My Messages. Also, we found Logout button in the top right corner allows you to log out of the training portal, where the username Xenia is displayed in the top right corner, indicating who is currently logged in. A new message notification is present from Dr. Doak. Clicking on this might display the message content. Based on the elements visible, we can infer that this web page is a portal for GoldenEYE operator training. It provides a central location for trainees to access course materials, manage their profiles, and communicate with instructors or other trainees. To open the inbox, go to My Profile in the navigation menu and click on Messages. Upon clicking on Messages, an unread message from Dr. Doak is displayed. Click on it to read the content. The message from Dr. Doak provides a hint. His email username is Doak. With the username Doak discovered, we can attempt a password attack against the POP3 service using Hydra. Run Hydra to perform a password attack on the POP3 service for the user Doak. Hydra finds that the password for Doak is GOAT. Let's use it to establish a POP3 connection to check if there are any messages or they're using Telnet. Run the list command to see if there are any messages. The server responds with a +OK1 message, indicating there is one message. Let's retrieve the message using the retr command. The message from Doak contains important information. It includes the username and password. These credentials could be valuable for gaining further access. With the credentials provided in Doak's message, we can attempt to log in. First, let me log out from the previous session. Use the username and password provided in Doak's message to log in. Upon a successful login attempt, a similar dashboard to the one seen before appears. Now, let's find out if there are any clues left for further escalation. Upon navigating to my profile in the navigation menu and clicking on the drop-down menu, it displays various options. One of these options, My Private Files, looks particularly interesting. Select My Private Files to look for any files that might provide further clues or information. In the directory, there's a folder named For James. Click on that directory. Upon doing so, a text file named s3cret.txt appears. This text file could contain important information that may lead us to further escalation. When you click on the file, it automatically starts to download. The contents of the file s3cret.txt provide several clues that may lead to further escalation. The text mentions that admin credentials were captured in clear text but cannot be added directly to the file due to security scans on web apps within the GoldenEYE servers. And the message also directs attention to a file located at /dir007 key /4-007.jpg. This location likely contains valuable information or resources. There is also a comment about the RCP-90 weapon and license to kill, which seems more like a personal note rather than a clue for escalation. Next, we need to access the file. To do this, navigate to the specified directory, dir007 key after the URL http 192.168.95.19, and locate the file 4-007.jpg. Here, I found an image, so let's examine its contents for any embedded data or further clues. First, we need to download it. We can use the wget tool for this purpose. Next, let's investigate the image using exif tool. Analyzing the file 4-007.jpg with exif tool reveals several key pieces of metadata. One specific piece of data stood out, encoded text in the image description field. The value in the image description field appears to be in base64 format. Let's decode it. Using the base64-d command to decode this value results in the string. This decoded string is likely a password or a key phrase. Finally, let's use this credential to log in as admin. In the username field, paste admin and paste the found string and password. Using the decoded string, we successfully log in as admin. Since we have access to the admin dashboard, let's look for an area where we can upload or inject a reverse shell script to gain a foothold on the server. Foothold. While navigating through various sections, I came across a critical area labeled System Path under Site Administration on the server. This section pertains to the configuration page within Moodle, specifically focusing on settings related to system paths. Let's examine each section to understand how we can use it to gain a reverse shell. To understand how to execute a reverse shell, I explored each section within the Moodle instance. I found a particularly interesting feature that allows inputting shell commands into fields designed for specifying the path to the Aspell utility. Aspell is commonly used for spell checking within the text editor. According to the tooltip, the default path for Aspell is typically /usr/bin/Aspell, but this can vary depending on the server's configuration. It's crucial to specify the correct path for the spell-checking functionality to operate effectively. After reviewing the details, I devised a method to initiate a reverse shell. This involves creating a reverse shell file and crafting a command that will download and execute it on the server. By clicking on the spell-check function within the Moodle interface, the crafted command aims to trigger a reverse shell, establishing a connection back to a listener set up for this purpose. So, we need to craft a PHP reverse Perl. To create a PHP reverse Perl shell payload, we will use MSF Venom. On terminal, run following command. Where -p is used to specify the payload type, that is, PHP reverse Perl, which creates a PHP script that establishes a reverse Perl shell. The L host is used to set the local host IP address, your Kali Linux machine's IP, where the reverse shell will connect back to. L port is used to set the local port on which the reverse shell will communicate. The -f, raw, is used to specify the output format as raw, which outputs the payload in its raw form. And the -o is used to specify the output file location and name where the generated PHP script will be saved. Upon execution, the payload is successfully generated and saved as reverse.php in the home Kali directory, which can be confirmed using the ls command. Next, we start a Python HTTP server. This command serves the current directory on port 8000 of our Kali Linux machine. This server allows us to host files locally, making them accessible via HTTP. Now, let's craft the shell command. Where, this command downloads the reverse.php file and saves it to the TMP directory, and then it will execute using the PHP command. Before we proceed further, let me start a listener using Netcat. Paste the crafted command in the Aspell path and click on Save Changes. To execute the command, find the Aspell path, which can be found in Edit Course or Create a new course. Navigate to Courses, then GNO, then Intro. Because editing is off, we cannot edit any file. So, click on Turn Editing Off to On. Now, editing is possible, so click on any of these. Alternatively, we can add a new entry by navigating to Siteblog found in Site Pages. Click on Add a New Entry, which will provide an area where you can write your blog. Add some input for general purposes. Now, click on Toggle Spell Checker to check if the spell checker is functioning correctly. However, after clicking Toggle Spell Checker, we noticed that a reverse shell connection to our listener was not established. To resolve this issue, we need to identify the problem. Navigate to Site Administration and then to Plugins. Under Text Editor Plugins, locate the TinyMCE HTML editor. Upon inspecting the settings, we discovered that the spell checker engine was set to Google Spell. This means that when the Toggle Spell Checker is clicked, it uses the Google Spell Check engine instead of Aspell, which is required for our reverse shell to work. To fix this, change the spell checker engine from the drop-down menu to pSpellShell. Return to the site blog where you add a new entry. Click on Toggle Spell Checker again. Now, we should successfully establish a foothold on the server. The interactive shell is not displaying correctly, so let's make it interactive using Python. Now that we have obtained a shell, it's time to check for the user flag. Start by changing the directory to home. Upon listing all files and directories, I discovered 3 directories: Boris, Doak, and Natalya. These seem to be the user directories on our target machine. Let's check each one for flags. Unfortunately, none of these directories contain a flag. It appears there might only be one flag on this vulnerable machine, possibly located in the root directory. Since we do not have user privileges to access the root directory, further escalation will be necessary to retrieve it. Privilege escalation. During the privilege escalation process, our main objective is to gather system information and identify any potential vulnerabilities or misconfigurations that could grant us higher privileges, ultimately allowing access to the root level. Previously, I discovered that we do not have user access to conduct user permission enumeration to know the user's rights and privileges on the system. However, we have found the passwords associated with the users, which we use to access the POP3 service. Let's use those passwords to check if we can switch to any of these three users. Upon trying, I found out that these three accounts are currently inactive. So, let's check if we can still perform privilege escalation directly from here. First, let's gather system information by executing the uname-init command. Upon execution, it prints out that the kernel version is Linux Ubuntu 3.13.0-32 generic. Let's search for an exploit using searchsploit. Upon execution, it provides various suitable exploits. Let's use one of these. I think the overlay fs local privilege exploit is suitable for our target. Before using this exploit, let's check if there is a GCC compiler available. Unfortunately, on the target machine, the GCC compiler is not available. However, there are other compilers like CC and Clang available. Let's check if CC is available. The CC compiler is available, so we need to modify the C program to use the CC compiler. First, we need to save the overlay fs local privilege exploit. Then, open it using a text editor and modify the compiler from GCC to CC to work properly. Next, let's send this modified exploit to the target directory. Previously, we created an HTTP server on the default port, which is currently running. So, it is important to specify a port. Change the directory to TMP. To download the exploit file, we will use the wget command. Now, compile the program using the CC compiler. Upon execution, 5 warnings were generated, but the exploit was successfully compiled. Now, execute it and check if we have a root shell. Upon execution, we obtained a root shell, which I confirmed using the whoami command. Since we have a root shell, let's change the directory to the root and check if we can find the root flag. If you have any doubts or queries, please write them in the comments section. See you then.